Hello, hi, good morning, good afternoon, depending on where you're located. My name is Shane Hollingsworth, as previously mentioned, and we thank VDW and everyone for attending today's quick seminar. We'll get touch base on who KAPP is, the markets we serve, and then also some of the products that we offer and the technology innovations we're seeing and developing to meet the market demands. Real quick, KAPP Niles is a family-owned German company. With the merger of Niles back in the late 90s, their historical background gives us over 100 years of gear grinding, gear manufacturing experience. The KAPP portion out of Coburg was developed in the 50s by the KAPP family and has grown into the KAPP Niles brand that we know today of approximately 1,000 employees. We are a global company. As you can see, our footprint is worldwide. Here in Germany is the headquarters, especially in Coburg. And we have in our facilities in Germany 2 primarily plants to build our gear grinding machines, Berlin and Coburg, as well as a secondary KAPP Technologies in Coburg for the tool manufacturing. In addition to our gear grinding assembly, we have our metrology division located in Grossosheim, which is near the Frankfurt area, probably closest to Aschaffenburg, where the design, development, R&D of our metrology products are taking place. And then here in North America, we have 3 facilities / locations for sales, service, engineering, development support. KAPP Technologies, who I work for, is located in Boulder, Colorado. That's where we primarily take care of our sales, distribution of the KAPP gear grinding machines, as well as metrology. Application support and service comes out of Boulder. The Dayton, Ohio facility is a Pentagear metrology as part of our acquisition and growth in the metrology division, supporting the controller development and sales and service support for the metrology products. In Mexico, we have a newly established facilities, KAPP Niles Mexico Technologies, as that's been a growing market for us over the last decade, with a strong growth in automotive, commercial vehicle sector. So the markets we support sectors are mobility, obviously everything with gears typically has some type of rotation or powertrain motion to it. Automotive industry is our largest division throughout the company, closely followed by the aviation market. In the aviation aerospace world, we have a long history there dating back to the 80s, where KAPP with the horizontal platform machines was founded with CBN technology, had a strong, robust brand there and continues that today. We've got applications in the main rotor drive, the engines, the turbine, so quite familiar for us and in a very good market for us in terms of supporting servicing worldwide. The VX series, the KX series, and our ZE to ZP platforms are the primary machine applications we see in that market. Robotics, industrial systems, conveyor market are areas that we have products producing finishing solutions. Cycloidal gearing in the robotics market, primarily we see over in Asia, and then obviously the industrial drives and conveyor systems. Automation as a whole, as we all know, with especially here in North America, with the challenge of the legacy workforce retiring and trying to bring in the next generation and challenges globally to compete. We're obviously always trying to optimize and give our best cost per piece scenario. So definitely automation is always a topic of conversation, whether it's supplying products for that or automation a part of our solutions that we provide to the market. The wind energy market here in North America is potentially looking at a comeback. It's interesting to see what the new administration will be, but we make large machines and solutions for those. And then another market we support quite strongly is the compressed air market, hydraulic pumps. We've got several OEMs here in North America that we are well aligned with and support. So we not only do gear manufacturing, gear finishing, we also do what we'll call profile finishing of non-traditional gear components. And with our customers, you'll kind of begin to see our theme through our discussions here is we're not just only a machine tool provider, we are a solution provider. So we provide the entire portfolio of products for them. So whether that's dressable grinding solutions, complete with dressers, fixtures, work holding, and or non-dressable technology. So you'll see the items in yellow are non-dressable tools. So typically for us, that'd be plated CBN, and then the items in blue are more your conventional dressable grinding applications. And our specialty applications on the far right there are typically non-dressable plated CBNs. One of the interesting things you'll find with KAPP Niles is quite the diverse portfolio we offer for our gear grinding, gear product machines, all the way from, I'll call it a job shop, low volume machine, all the way to high volume automotive, to precision aerospace, up to 8-meter gear grind applications. With our diverse portfolio, it's a great asset of ours that allows us to serve a lot of different markets at one time. And you kind of see the blend. Our top line is generating machines, primarily the KX line is our dominant for generating, and then we'll see the VX, ZE, ZP platforms are primarily profile. And we have some combination machines such as a KX Twin and our KX300, KX500 product line are capable of both things. The expansion of our business, since we have for over 30 years provided plated CBN tools, approximately within the last 10 years, we started in the diamond tool business as well, taking our lessons learned and experience and applying into that market. So we manufacture our own diamond tools for our dedicated profiles and or diamond dressing gears, depending on what the market requires. And this is kind of an overall portfolio of some of the grinding wheels, grinding tooling dressers that we support in our market. The plated CBN, as I mentioned, the CBN grinding worms, dressable wheels, profile grinding dressing rolls, gear honing, so on and so forth. Today we're going to touch on 4 of these points, which will be the topological generating profile grinding, generating grinding small tools, super finishing, digitization, and industry 4.0. All these I would say are developments in the last 5 years that we began. Some are mature developments, some are still in innovation, and some are evolutions of current development. So as we see some of the next generation demands in the aerospace markets, obviously the wind market technology, in addition to now the automotive shift from what we'll call the 6 speeds to the 10, to the 6, 8, 10 speeds, and now the EV hybrid evolution and what those gears require for the applications that they're serving. We'll start with topological generating and profile grinding. So in here, and maybe on the next slide, you'll see the charts. But with topological grinding, we are controlling what we'll call the twist or bias influence from the natural grinding operation. So we dress the grinding worm with a modified approach, and then with the kinematics of the machine between the shifting and the stroke of the grinding wheel to the workpiece axis, we're able to control the amount or input the amount of bias twist depending on the design specifications. The other thing I want to point out here is you'll notice later on a slide we'll mention again is the zones here that you see the contact with the wheel. So this chart actually could go either way. In one way, you can have natural bias where we let the leads and profiles follow the natural way depending on the generating kinematics. The other way, right, is we can force or create that with the lead and profile. And just taking a quick step back with bias, if you're not familiar, on the profile, we're taking measurements of 3 sections along the lead, and on the lead measurements, as the top one is profile on the left, on both, and the bottom is the lead. You'll see we'll take 3 sections along the profile, so out towards the OD, maybe more towards the mid-tooth, and bottom towards the SAP. We'll take slices along the lead and measure the actual involute and lead at those specific locations. And like I said, depending on design application and what's intended for the process, with the software, the special dressing of the wheel, and the kinematics combined, we can, create a desired bias or twist and or remove that so that you have, no matter where you check along the tooth or face width, you have we'll call maybe pure or theoretical involute or leads. First probably saw some of this in the automotive wind industry, and now we've definitely seen significant growth. It's been in automotive, but definitely with the push of EV and the size of those gearings. Obviously, when you don't have a ICE engine that creates noise, the road noise from the tires and transmissions is the primary noise maker. So noise sensitivity, life becomes much more sensitive, and contact ratios and controlling those patterns are a significant topic when we're in that market. This just gives a snapshot of what the overall look of the input for that is. Actual shifting areas, possible shift areas, primarily where we work in 3 zones with the grinding wheel, but this is all controlled through the HMI interface and software development of the target. So how we manage the shifting, the grinding strategy and technology is all done through this screen. Generating grinding with small tools. What is maybe the first definition, right? It always asks is, what is small? And that definition keeps changing as we develop more and more. In the CBN world, and we'll have an example just to compare it to, we've, small CBN grinding, specifically profile CBN grinding, is a common developed technology that we've had for a number of years. Now that obviously you're looking for more productivity, we've seen this transition over to generating grinding wheels. And now we're talking generating grinding wheels approximately, 200 to 50 millimeter kind of classifies as small today. With those, obviously, several challenges involved with that. One is controlling the wheel life and some of the developments with the new grinding wheels and technologies that we've seen in the last 5 to 7 years, up to the last 10 years. There's been a significant enhancement and growth with dressable tooling technology. And then also, the speed of the spindle and controlling that with the speed of the work table, and all that has to be in harmony with the work holding fixturing. So becomes a very complex system very quickly. You would think smaller is simpler than bigger, but not always the case. So we've got an application example here. Obviously, this is one where we're not at the small end of, say, a sub 100 millimeter grinding wheel. This application example, I think, is roughly around 150 millimeters. But we have the interference contour that we're going to be generating grinding up against. This is a common commercial, large commercial vehicle wheel. So the first steps, obviously, is we have to check for collision interference. We need to design the appropriate, for the appropriate wheel diameter, so that one, we don't obviously have the collision to destroy the grinding wheel. From there, obviously, we choose the wheel type we want to use, potentially number of starts. I apologize, it says threads, but it's number of starts. And it looks like in this application, we've selected 150 millimeter worm wheel. So as I mentioned earlier, typically this process would have been with a profile CBN wheel, grinding time roughly 5.5 minutes. You would have had a dedicated tool, maybe a little bit more higher cost profile CBN. And now with the new technology, with the addressable worms, you have maybe a similar equivalent cost tool, but obviously we get a little more life. It's a perishable item, and then our cycle time is actually under 3 minutes. So we're seeing almost a 50% reduction. And of course, as we see more and more applications coming down the pipeline, we will see more demands on where does this go. Obviously, the discussion around addressable CBN is in this topic to increase throughput on tool life. But again, as we mentioned, some of these RPMs we're getting up to is 25,000 on a spindle. As I mentioned earlier, we have actually certain applications with profile CBN where we're actually running on 60,000 RPM spindle with a 10 millimeter wheel. That's a long ways away from where this generating technology is at, but there's definitely a growing market. And as we see again with planetary designs coming into EV markets, shoulder clearances and interferences are definitely becoming a norm on some of the pinions. And we've got an example gear chart for what we actually produced from this application. Super finishing, always an area of interest. Profile finish on the physical part themselves. What we call, basically with super finishing, this is a software technology development along with a hardware requirement. So in this picture here, we see basically two grinding wheel types sandwiched together or glued together. The first area is more of the conventional grinding dressable wheel, and the second area is the super finishing wheel itself. So obviously we still have to grind a very good gear with a very good finish to be able to polish down to the required finish. And then the conventional process prior to this would have been that the end user would have had to grind a gear, then take it off, put it in a chemical finishing process, and bring it back to the machine to bring it back. So it adds logistics costs, potentially additional tooling investment and capital that becomes more of a headache in that. So it's quite nice to be able to finish and to get these RAs of 0.1 down on a single manufacturing process. This is an application workpiece example. These are actually two gears sitting side by side. They're not one gear, but this gives you an idea of what what to expect. So this is a little bit different wheel type as you see in this picture. We're using a Krebs and Rito wheel with an Artifex polishing wheel. 3 starts, cutting speed 63 meters per second. Approximate machining time is about 2 minutes. So in general, we're not seeing a massive increase in our cycle time. Yes, we're seeing a 50% increase, but in terms of taking that offline to a secondary operation and managing the logistics control, this has been a significantly growing interest. Several of these are in production. Again, the EV world, aerospace applications have a lot of super finishing requirements, and potentially even in the wind industry. So it's always nice to complete a process in a very controlled environment. To take a step back with the conventional grinding wheel, we still have to make a very good quality surface finish, because when we're grinding with the polish wheel, it's more what you expected here, polishing. So material removal is very, very minimal, if not none at all, and we're just bringing that surface finish to life. This is a nice visual representation of the charts that we get. And as the evolution of super finishing continues to grow, I'm sure it's not very long ago you remember seeing that we had one value of finish requirements that typically were on part drawings. And now we're seeing multiple characteristics that must be met and controlled. So the chart on the left is before super finishing, maybe what we'll call a typical ground gear. The chart on right is after super finishing, where we're seeing over half reduction in the another visual representation of what the tooth flank surface looks like. Obviously, when you're maximizing surface wear and durability, trying to minimize noise and extend life, typically the high points are your failures for surface, and the idea here is to minimize the high points. So visually, this is another visual 3D representation of that. The last topic is probably the one that I consider out with opportunities, I'll say. When we look at this here, you definitely hear a lot about data, right? The cloud, Industry 4.0, digitization, where do we go with that? What do we do with that? And there's multiple challenges here that have to be worked through. You've got customers with their own platforms. You've got customers who are looking towards the OEM for their platforms. and where does we go with all that? And so the question always becomes, what can we do to help support, and where do we fit into support? So in some cases, we're literally providing the data, and a customer analyzes that and does their own analysis. So then we need people who have a standardization, such as Umati, MT Connect. MT Connect's a little more common in North America. But then what can we do with the data, right? We have some of the production aspects, control, where we can see the number of cycles we're putting on arbors and fixtures and dressing tools, how many grinding pieces. We've got closed loop, we've got production monitoring. In the data processing world, we have traceability, condition monitoring, process monitoring. And the service side of taking this data, we can do predictability, when to do maintenance manager for logging information, remote service, not only for us, but for you as a customer. So this is a tangible item that not necessarily when you think of a gear grinder provider that as a machine tool provider that you typically have this tied associated with it. But in the last 3 to 4 years, this market and the requirements are growing drastically, and the data we can accrue is very large. And then we take this data and what to do with it. So we're going to focus next on one thing we do with this data. Let's see if we get this to, there it goes. So closed loop, definitely a hot button in the industry for manufacturers today. And what is closed loop, right? I think if you are familiar with bevel gear manufacturing with the CNC technology, that's been well established and well known for a number of years. It's now entering the parallel access world. What we're doing with the closed loop is we're taking actual data measured on an analytical inspection machine, putting that into a format that then a GDE standardized format, which seems to be a common practice use, which is nice when you're trying to use different inspection machines versus different gear grinders. And now you can take that data and put it back in the gear grinder, and the gear grinder takes that information, analyzes it, and then decides how to interpret it. One of the nice things about this, right, is what characteristics are being controlled. At the moment, we're offering 3 characteristics with the 3 characteristics. We have lead and profile slope error, and then we have the size control for the 3 characteristics that we're monitoring or help closed loop. And why is closed loop so important, or why is closed loop gaining so much attention? And as I mentioned a couple of times throughout my conversation here, that what we're seeing in the marketplace is the workforce that we had in place that had the experience, the know-how, and what to make changes is retiring and moving on. And now we have a new generation coming in that maybe didn't start with mechanical machines, or is going straight into CNC manufacturing. So they're missing that step of the learning process. And in turn, they don't have some of the skill sets that there. So how do we take some of that skill set and put it into, basically, to some extent we can refer to as AI, or artificial intelligence. This is one of the screens that tells us, pull these up real quick, that is in our software when we're talking in closed loop, which is on the gear grinder. So we have a bandwidth here, right? Not every time that we get a data back from the inspection machine does a change need to be made. So we can set bandwidths here that are obviously controlled by the user, how wide, how, of no correction, or stop, you've got a gross error. In addition to what's nice about that is there's a log process that follows. So you can go back and look at when a measurement received, did we accept the changes then? Did we not accept the changes? What does, what is this indications telling us? So to me, I there's lots of discussions about the benefits and values here, and I always come back to maybe the number one thing is just go back in your shop and maybe ask yourself how many times has a size error been made, and no matter what machine is been done on, right? Whether it's the green process, the finishing process, if that one single aspect can help be controlled through technology, and we don't have a fat finger of say 10 microns versus 100 microns. This software becomes very powerful very, very quickly. Lastly, I'll talk quickly on our metrology portfolio that ties in with the closed loop process. KAPP Now's Metrology has launched a new product line, the X series, a couple years ago. we've developed pretty much what we'll call a mechanically wear-free solution. We're using all granite design for the measuring column, the base, air-bearing table. With our moving axis with the measuring column, we have air bearings and linear motors. So we have no mechanical items to prevent premature wear or failure. And similar to the gear grinding portfolio, we have our small size platform machine for job shop to automotive use, up to we're building a 5-meter gear inspector machine at the moment that'll be installed in North America later this year. So quite excited with that product and this accuracy. Obviously you'd have with the accuracies requirements that are growing on or increasing on our gears, we have to have the finishing machines keep up with that, but in turn, we also must have the inspection capability to follow. In addition, we do some repowering of smaller machines to extend their life, as well as double flank checkers, DOB gauges that we supply as far as our control metrology group. This is a picture of our Boulder facility. I appreciate everyone's time. I apologize if it seemed a little fast, but we want to give you a nice overview of some of the technologies and challenges that we've been working on, and would now open the floor to any questions that you may have. One question that did come through that's quite interesting in my opinion, and is always unique to hear, is the question is what can a good gear be bad? And what I mean by that, or I think what the question means by that is, can we make good gears that meet all the charts, but our customer comes back and says it's no good? And the answer to that is yes. Actually, the conversations are very, today where I think if you were part of our virtual expo we had last fall, we kind of talked about this a little bit, but we can make a good gear, meets all the chart interpretations, and then when we put it in the, call it the assembly, it excites a harmonic or frequency that fails a transmission test. And some of the things that we're doing when we run across those problems, they're very unique and, take a significant effort through our service group, but we go back and we can analyze the harmonics and frequencies between the grinding spindles, the grinding table, and see how that order is being, actually shows up in the gear measurement itself to, then we'll say make a bad gear in the transmission assembly. So yes, I can say that is possible. Like one more question we had was about the different types of finishing, referring to the super finishing aspect. There's a common word or technology we hear is fine grinding, and is fine grinding the same as polish grinding? And the answer to that is no. Fine grinding is still using more of a conventional grinding wheel, but with a modified technology where we hit a middle ground on the finish. I'll say you have a conventional gear grinding finish, you have your fine grinding finish, and you have your polish grinding finish. So we do use a little bit different wheel, but we're not using a polishing wheel for the fine grinding. Well, that looks like all of our questions we had. I appreciate everyone's time and for joining. And I'm going to turn it back over to our organizer.